Minors and cofactors. Let A which equals to aij n times n and aij be the submatrix of A obtained by deleting the ith row and jth column of A for ij 1 to 3 up to n. Then the first is the minor for A at location ij denoted by Mij is the determinant of the submatrix aij, that is Mij which equal to determinant aij. Second, the cofactor denoted by Cij A for A at location ij is the side determinant of the submatrix aij, that is Cij A minus 1 I plus j, determinant aij. And the practical examples on minors and cofactors is like this. A which equal to 1, 0, 2, 1, 1, 3, 2, 0, 1. Let's use the minors for 1 and 1. 1, 3, 0, 1. 1 minus 0, it must be 1. M1, 2. 1, 3, 2, 1. It's become minus 5. Multiplied by them and subtract them. M1, 3. 1, 1, 2, 0. It's become minus 2. And the minors 2, 1, 0, 2, 0, 1, it's become 0. And the minors 2, 2, 1, 2, 2, 1 must be minus 3. And the minor 2, 3, 1, 0, 2, 0, it's become 0. The minors 3, 1, 0, 2, 1, 3, it's become minus 2. Then minors 3, 2, 1, 2, 1, 3, it's become 1. Minor 3, 3, 1, 0, 1, 1, it's become 1. So let's see the cofactors here. On the first row must be positive, negative, positive. On the second, negative, positive, negative. And the third, positive, negative, positive. So 1 is the positive. Negative, it must be minus 5, we cancel 5. Positive is negative 2, but there's negative, we can say no need of neither positive nor negative. So 0, negative 3, 0, negative 2, because here's 1 here, put negative, negative 1, and 1. So this is the correct situation as we have determined. And the systems of equations in 2 or 3 variables with the matrices and determinants. If we interpret x, y as coordinates in the xy plane, then each of the 2 equations represents a straight line. And x star y star is a solution if and only if the point P with coordinates x star y star lies on both lines. An example is x plus y which is equal to 1 to x minus y which is equal to 0. It includes 2 variables with one over here. By using by 3 methods like substitution, elimination, and graphical. So x plus y which is equal to 1 must be mixed with the interchanging by variable y into the x. Y which is equal to 1 minus x. Put the y variables with the 2x minus y here out of the factorization. 2x minus y is given 1 minus x equal to 0. 2x minus x minus 1 is equal to 0. 2x minus x is equal to 1. X which is equal to 1. Then x we get it 1. Now on the second here, x plus y which is equal to 1. The x value is given 1 plus y which is equal to 1. Y which is equal to 1 minus 1. So y which is equal to 0. We can say the solution set 1 and 0. Matrix form linear system in 2 or 3 variables. From the definition of matrix multiplication, we see that may be written as a single vector equation. May be written as a single vector equations are known as the coefficient matrix, the column vector of unknowns, and the column vector of numbers respectively. We assume that the coefficients aij are not all 0, so that A is not a 0 matrix. Note that X has nx component where B has m components. Gaussian elimination method. And the Gaussian elimination method, also known as row reduction, is used for solving a system of linear equations. It is usually understood as a sequence of elementary row operations performed on the corresponding matrix of coefficients. Then the idea here is we solve the linear system whose augmented matrix is in row echelon form, which is row equivalent to the original system. And we have the following theorem on the row equivalent linear systems. Thus, if the augmented matrix is initially in row echelon form, then we simply solve it by using back substitution. If it is not, then first rewrite it as a row equivalent system whose augmented matrix is in its row echelon form, and then apply theorems. And the practical examples on Gaussian elimination method is like this. Like example, x plus 2y plus z equal to 2, x minus y minus 2z which equals to minus 1. Let's take it out by using the augmented matrix AB, and 1, 2, 1. There's 2. 1 minus 1 minus 2 minus 1. Then the row 2 must be subtracted with row 1. 1, 2, 1, 2. There's 1 minus 1 is become the row 2, 0. Minus 1 minus 2 must be minus 3. Minus 2 minus 1 must be minus 3. Minus 1 minus 2 it's become minus 3. Then the row 2 must be divided by negative 1 over 2. So here 0 times minus 1 over 2, it becomes 0. 1 times minus 1 over 3. Here minus 3 times minus 1 over 3, it's become 1. Minus 3 times minus 1 over 3, it's become 1. Here minus 3 times minus 1 over 3, it's become 1. X plus 2y plus z equals to 2, y plus z equals to 1. The infinite solutions 1 minus alpha, alpha 1 minus alpha. Alpha is the real elements with the whole real numbers. This is all about in our programs. Thanks for listening.